Okay, looking at 17 through 21 now. I'm not going to take the time to work out all of these, but I'll highlight a few things. First of all, number 17, we're looking for the circumference of a circle with a radius of 1, 2, 3, 4 units long. But also remember when you're trying to find the distance between points on a horizontal line, you just subtract your x coordinates. It's the absolute value of the difference of the x coordinates. So 3 minus negative 1 gives me 4, or negative 1 minus 3 gives me negative 4, but the absolute value of that is 4. So the radius here is 4 units long. All right. So I can use either one of these formulas to find the circumference. I'll use 2 pi r since we have the radius, which is 4 units long. So circumference is 2 times pi, which they tell us approximate as 3.14, times the radius, which is 4. So what we'll end up with is 8 times 3.14, which is 25.12. Okay, and again, remember that's an approximate value of the circumference since we are estimating the value of pi. All right, so this is 4 units long. Number 18, I'm not going to work it out, but to do number 18, well, here you have a vertical line, so you could just subtract the y coordinates 4 minus 1, and this side is 3 units long. We're asking for the perimeter, so we have to add the sum of the length of the side, add the length of the sides. So for these two line segments, we'll have to use the distance formula and then add those up, and you should end up with 11.16. Same thing with number 19. We've got a vertical line here, so we can see that this one's 1, 2, 3 units long. Okay, and 4.5. That looks a little small there. Hold on a second. Let me pause it. Okay, I was wrong. We're dealing with area. I didn't read the directions here. I thought the directions up here were for all 4 of them. So the area of the figure is what's being asked here. So in this one, we're asked for the area of a triangle. So that's 1/2 the base times the height. All right, we can, the height is perpendicular to the base, so we can simply see here that the height is going to be 1, 2, 3 units long, and the base is also 1, 2, 3 units. So we just have 1/2 times 3 times 3, which is 4.5. Okay, and then again we've got vertical and horizontal lines, so we can see the distance between the points here. This is 3 and so forth, and this is 6.5 minus 2, which is 4.5 and 3 units, and then this is also going to be 4.5 units. Okay, and as for the area, so that's just 3 times 4.5, which is 13.5. Okay, looking at number 21, Tony walks from point A to point B and then from point B to point C. How many feet could he have saved by walking on the diagonal sidewalk from point A to point C directly? All right, so what we're going to have to do is just compare the distances. So from A to B, we're told that each consecutive grid line represents 4 feet. So from A to B, we have 12 feet, and from B to C, we have 20 feet. So walking this way, we have a total of 32 feet. Okay, and then to find AC, we could either use the Pythagorean theorem or our distance formula, but what we're emphasizing now is the distance formula. So the distance from A to C is going to equal the square root of, the coordinates for A are 0, 12, and the coordinates for C are 20, 0. So we're going to subtract our x coordinates. 20 minus 0 is 20. So we have 20 squared. And we have subtract our y coordinates, and we have 12 squared. Okay, so 20 squared is 400. and 12 squared is 144. So we have the square root of 544, which is equal to 23.32. Okay, so subtract that from 32, and I have like 8.68. If I round to the nearest thousandth, I have 8.68. So that is about 9 feet. Okay, there's about a 9-foot difference. It's around the answer to the nearest foot. So there's about 9. You know, this route here is 9 feet shorter. Okay, so again, the square root of 544 was approximately 23.32. And again, that's an estimated value. And that's not a very good symbol there, but okay, it's estimated since we're rounding.